Alright, so in this section, we're going to be talking about functions. This covers section 1.4 of your textbook. We're going to be seeing a lot of old terms involving graphing and how numbers relate to one another. We're going to use, at this time, just two variables. So we're going to talk about domain, range, and then at the very end, we're going to take a look at how it applies to some real-world problems. So let's go ahead and get started. A couple of definitions we need to be familiar with and just remind ourselves of. Here we have the first one is a relation, and that is simply the set of input and output values. It's a pair of numbers and how they are related to one another, just as the word says. Often we write those as ordered pairs, such as -7, 0, -3, -2, and so on. The domain of any relation or the domain values are simply what we know as the input or the x coordinates of the ordered pair. Those values are said to be independent. Domain values happen no matter what. Then from those domain values, we have the range, or as we often call it, the result of those input values or the output values. In our terms, we look at it as the y values of that relation, and it is dependent on the input. Can't get a y value in functions until we know what the input value is. We put something in, we get a value out in return. And in that case, for it to be a function, it's a relation in which each element of the domain, notice this, the domain, has to be paired up with only one, exactly one, element in the range. That is, the x values themselves are not allowed to repeat in order for it to be a function. We can represent them in several ways. Verbally, we can simply say yearly interest earned on $1,000. We can say numerically with things like tables. The input value is 1, 11 is the output value, 2, outputs 10, 3, 8, 4, 5, and so on. Graphically, whether it's a standard graph that we're used to with points that have been plotted, or something like this thing down here, this box with arrows and numbers and so on, time of day in the PM, the temperature in Celsius as a result. That means in this case at 1 p.m. the temperature was 9 degrees Celsius. Now you're thinking that's probably pretty cold. And it's not as cold as you think. When it comes to Celsius, keep in mind 0 Celsius is about 32 degrees Fahrenheit. It's 9 degrees Celsius is still chilly, but it's not too bad. And then about 20 degrees Celsius is 68 degrees Fahrenheit. So it's cold, but not as bad as 9 degrees sounds at first. Another way we can talk about this is algebraically with equations that we're familiar with, such as y equals x squared, which is very similar to this graph here, and we're going to explore those type of equations a little later. One question you might want to ask yourself is something like this: x squared plus y squared equals 25 a function. So the first thing you want to do is in fact solve for y. If it says y equals, it's a little easier to tell if it's a function or not. So let's go ahead and do that first. We start off by saying, okay, I'm going to subtract x squared from both sides, trying to get y by itself. So I do that. Then the next thing I got to do is I got to get y by itself. And it's almost there. I just got to get rid of this guy right here. This squared has got to go. And how do you get rid of a square? Well, you take the square root of both sides. Be very careful when you do that, though. Because one thing you want to think of is, okay, what is the square root of 25? And you're thinking, okay, what times itself gives you 25? And well, that's 5 times 5. But what is -5 times -5? That's also 25. And because both of those can give you 25, you don't know where that 25 came from, you have to consider that you took the square root. So anytime you take the square root within an equation, you have to say plus or minus. So you have to say that y is equal to plus or minus the square root of 25 minus x squared. Also, I know it's tempting to simplify this. You cannot simplify square root of 25 minus x squared. 25 is a perfect square, and so is x squared, but you cannot separate those because of this minus. Do not chop that up and try to simplify that. That's as simple as that equation can get. Then let's answer the question we just had a second ago. Is this a function? Well, that plus or minus is trying to tell you something. And because plus or minus is telling you no matter what x value I put into this, or most of them, there's only one exception, whatever x value that I can put into this equation that provides me with an answer, I'm going to get two y values in return. So each input value is going to give me two y values along with it. So this is not a function. That plus or minus is usually an easy way to tell. This might not work, but it's not always the case. Best thing to do is, if you can, solve for y and then go from there. Our next portion talks about function notation. That is, it's going to replace y with f of x. So when we're talking about function notation, we talk about y equals. And instead of saying y equals, we can say f of x equals. We can replace y equals with f of x equals. That is, and exactly that. It is a function of x. You don't have to question it. This is telling you right away. If you see f of x, that means that this is a function of x. And always read that as f of x, not f parentheses x or f times x. So we're asked to evaluate f of -3, f of 0, and f of 5, meaning that x has now become -3, 0, and 5 in three different situations of the function -x squared plus 2x minus 1. So at this point, if you would like to try these out on your own, go ahead and pause the video. If not, let's take a look. On this first one, we plug in, and you got a little bit of a sneak peek of what the answer should be. You plug in -3, and this is what we come up with for the answer. Now, if you did not get this same answer, keep in mind that, first of all, I'm substituting -3 into something that already has a negative in front of it. When I plug that in, you have to be very careful that this reads negative and then parentheses. And then the next one is going to be -3 squared. You have to be very careful with that. It's easy to just say, oh, there's a negative there, so I'm just not going to worry about it. That's taken care of. No, because the negative gets squared and then it comes back. So then it becomes -9. And if any mistakes were made, this is where they would have happened. This becomes -9, and then this one is -6, and then this one right here is -1. And that's where we get the -16 as your final answer. The next one is super easy, because if I'm asked to replace a 0, if it's got an x, it's going away. So for this next one, we're looking at 0 squared plus 2 times 0 minus 1, and that's only going to be -1. Last one asks you for what is f of 5? Well, f of 5 means that x is now being replaced with a 5. Notice it does not take place of the negative. The negative is still outside. I'm only replacing for the x. So it becomes, in parentheses, negative on the outside, 5, then squared, which is 25, and then 5 squared, 25, and then make it negative, becomes -25. And then plus 2 times 5 becomes plus 10, and then -1. And this is equal to, in fact, -16. Notice there's a similarity there. We had -3 for the input, and the output value was -16. We have 5 for the input, output value was -16. Is this a function? These two values repeated, does that make it a function? Don't let that throw you off. Remember what this said. This is a function of x. The y values are allowed to repeat. We're often, almost inclined to say, well, that's not a function. I have a repeated value. That's something completely different, and that's okay if the y values or the function values repeat, as long as the x values don't repeat and give you different y values. I can have different y values with different x values instead. So just keep that in mind. It's okay if the y values repeat. It's not okay if the x values repeat. And a bonus question, for what value is the whole function equal to 0? For the function above, negative x squared plus 2x minus 1. So what value would make this whole thing equal to 0? So let's give us a little bit of room to work with here. And if you would like to try this out, go ahead and pause the video. If not, let's take a look at how that is done. If the whole thing is supposed to be equal to 0, that is negative x squared plus 2x and then minus 1 is going to be equal to 0. So I set the whole thing equal to 0, and you have a couple of options on how you want to go about solving this. You can do the quadratic formula if you know it. If you don't know it, an easier way, especially in this case, would be to factor it. There is something I'm going to do before I start factoring, though. I don't like dealing with a negative in front of the x squared, but it's a real easy thing to do. It's just one of those rules of algebra that I can just reverse all the signs for everything. It's almost like you're dividing by negative 1. And then that makes it negative 0, which, of course, is just 0. Next thing to do is to go ahead and say, okay, I'm going to factor this. And in factoring, you're looking for two things. One that says it multiplies to this here, multiplies to positive 1. And then the next thing you're going to look for is what it adds up to, which is negative 2. So two numbers that multiply to positive 1 and add to negative 2 are going to be negative 1 and negative 1. This was a pretty straightforward factoring problem, so not too much to it. When we get to a little more complicated one, I'll show you a trick in factoring. And if you're comfortable enough with it, then you can continue to factor however you're used to. But remember, the quadratic formula also works in this case because we're looking for numerical values. And now for the last part, we're talking about these two things multiply together equal to 0. There's only one way you can multiply to get something to equal to 0, and it's if either one of those things are 0. And in that case, we use something from algebra called the zero product property. Not important to know, just important that you know how to use it. That is, the two things that multiply, either this one or the other one, has to be equal to 0. So we set each one equal to 0. Now you're probably thinking, you didn't really have to do that. And you're right, because they're exactly the same. You can just solve it once. So for that matter, I add 1 to both sides. I get that x is equal to positive 1. So when x is equal to 1, the whole function is equal to 0. All right, the next thing we have when it comes to domain is something that we call the implied domain. That is the set of all numbers for which the function can be defined. For the most part, every domain, every equation has something that you have to watch for, especially if there's when you put things into words, or when you see things like this one. This one right away is telling me, hey, I have a fraction. And one thing that's never allowed when it comes to fractions is division by 0. So that's the first thing I need to watch for. I cannot have division by 0. So if you see a fraction where x is part of the denominator, now I have to be concerned with values that just won't work in this equation, or values that I have to exclude from my domain. So I take the bottom of my fraction here, which is x squared minus 9, and I cannot let this be equal to 0, because if I did, then Cookie Monster would have no cookies and you would have no friends. Remember, division by 0, just ask Siri. Now I add 9 to both sides. I get x squared is equal to positive 9. Then, to get x by itself, I take the square root. When I take the square root of both sides, I get square root of 9 is 3. Now remember, we took the square root. So because I took the square root myself, I have to consider that could have been plus or minus. So my domain for this function here is every value that you would like to use except for 3 and negative 3. It will not return an output value because division by 0 is undefined. The domain is all reals except for x equals 3 or negative 3. There's a few ways you can represent that. You can simply say x is not equal to plus or minus 3 is your answer. You can say all reals except for x not equal to plus or minus 3. So now, for your practice problem, I want you to find the domain of each function. So go ahead and, if you would like, pause the video and try these out on your own. If not, let's go ahead and take a look. So for the first one, the domain is simply all of the x values. So we look at values like negative 3, negative 1, 0, 2, and 4. Simply just the x values, or all the input values. Alright, now part B, we just got done talking about. We see a fraction. Now we have to worry about division by 0. So in part B, division by 0 tells me that I cannot have the bottom of this fraction equal to 0. That means x plus 5 cannot equal to 0. So it might be easy to say that this one, x, cannot equal to negative 5. Just solve for x. Alright? Now the next one is the volume of a sphere. Volume of a sphere, well, there's no division where, I can have, the bottom of my fraction can be equal to 0, so I can't, necessarily have division by 0 here. But the key, and remember what the word talked about, we're talking about implied domain. We're talking about volume. Volume has to be a positive value. So for the last one, all reals except for negative 5. But we're talking on part C, it has to be a positive value. It's implied because it's volume that we can only use positive values of R. It's not really a sphere if it doesn't have a radius. And a radius, a measurement, cannot be negative. Alright? Now that takes us to part D, and part D is probably the trickier one. Because now we're talking about square root, and you're thinking, I don't have division, put anything you want in there, right? Well, depends. In this case, there are some restrictions to square roots. We know that when it comes to square roots, everything that's inside the square root, in order for you to create or generate a real answer, what do we know about the things that are inside the square root? They have to be positive. So all the numbers inside of a square root have to be positive. It can be equal to 0 because the square root of 0 is 0, that's fine. But in order for it to be positive, we're now looking at values that are greater than or equal to 0. And so we're solving instead an inequality. So we start off by saying, okay, minus 4 to both sides, minus 4. And so I end up with negative 3x is greater than or equal to negative 4. Then I divide by negative 3 on both sides. Divide by negative 3 on both sides. I end up with x is greater than or equal to 4 over 3. But then you're probably thinking, wait a minute, is it greater than or equal to? Because if you put in a number like 10, this becomes 4 minus 10, let's say. 4 minus 10 is negative. So now, well, the number inside the square root is negative. Don't forget, way back when in algebra, we learned that anytime we divide by a negative number, we have to flip the inequality. So we're not actually looking for numbers that are greater than this time. We're actually looking for numbers that are less than. every number that's less than or equal to 4/3, I can use inside the square root. All right, less than or equal to 4/3. Don't forget, flip the inequality when you divide by a negative. It's one of those old rules of algebra that we learned a long, long time ago.